Image recognition technology has been taking the mobility sector by storm. So we're very, very happy that the next workshop is going to be all about image recognition technology. Yes, if you want to build your self-driving buckwheat, it's definitely something that you're going to be leaning on quite heavily. Now, to present this technology, we have two of ProRail's data scientists. They were going to be here in the studio, but one of them had a fever in the family, so we thought it'd be safer if they recorded it from home. Both of their names are Oscar. We're very, very happy to have, broadcasting from home, Oscar van Hees and Oscar Enzing. Oscars, take it away.
Hey Oscar. Hello everyone, and welcome to the ProRail Masterclass Image Recognition. Well, first Oscar, I have some good news. I don't have COVID. Whew, that's good. Yeah, and even better news, we can now film the whole image masterclass at home.
At my home, actually, in Rotterdam.
But of course, the masterclass is for you, and after this masterclass, you will be able to have a good idea of how image recognition works, how it's applied in real-life scenarios, and you will have used it yourself during the hands-on. But first, let us introduce ourselves.
Well, like I said, I'm Oscar, data scientist at ProRail.
And I'm Oscar, data scientist at ProRail.
What a coincidence.
Wow. Today we're going to start by talking about ProRail as a company. So what does ProRail do and what role does data science play at our company? Next we're going to focus on computer vision. How does it work and what is it used for in general? Finally we'll focus on the hands-on, where you will be able to perform image recognition yourself using the camera in your own laptop. And finally, we're going to even update the image recognition model using photos from you. For this we have some instructions. But first we want to check whether everyone has Python installed as well as the environment, as we instructed beforehand. Or if they have found a teammate that does have Python in the right environment. Because we will be live in the chat for any questions. So if you have any trouble with setting up the environment, you can ask us now in the chat. And during the whole presentation, we will be available in the chat for any questions, so you won't be interrupting us since this isn't live. And for the live aspect of the demo, we want to update the model using your pictures. So we're going to give you 5 minutes now to send the pictures, and we want 3 pictures of your hands. And try to be creative. You can try different shapes and positions, and we would like you to send them to this email address, oscar.enzing@prorail.nl.
thank you all for all those very good images of your hands. But first, let's have a little talk about what ProRail is and what we do. ProRail is the owner and maintainer of all the railway systems in Holland. And that means that we create an infrastructure for train operators to drive on, like Nederlandse Spoorwegen or Arriva. And that means that we have a lot of assets. For example, we have 2,400 crossings or 7,000 kilometers of track, 7,000 switches, 400 stations. And actually we are one of the biggest landowners in Holland. And we have to maintain all those assets. And as ProRail we focus on three main challenges. The first one is that the mobility is growing these days, even though with COVID nowadays, but actually we're still growing. And that means that we have to grow as well. So we have to grow with our demand to keep up with we have to grow with our supply and to keep up with the demand. Or else Holland is left with a big mobility problem. The next challenge that we face is that we have to keep up with the technology as it is developing rapidly. We have to turn the tide of the growing number of defects by keeping up with those technology, because we have to do the same with the same amount of money, but we have to do it better and better because of the mobility growth. And finally, the world faces with a big issue, and that's why we have to be sustainable as well, because we think that train is one of the greater options, more sustainable options to provide transport over railway systems. So our target is to keep it as sustainable as possible. And it results in the following pillars. ProRail connects, ProRail improves, and ProRail goes green. What we do is with data science as well.
I'm going to tell you a bit more about that. So ProRail has been using data science for a few years now. And it actually all started as usually within innovation. So first the data lab was put up. It was about 4 years ago that the first experiments started. And the data lab is a lab environment, as you can imagine. It's collaboration between different business units within ProRail. And it allows anyone in the company to just come there with an idea to try a data science project that can help their daily work. And we work a lot with the sensor lab as well, which is another lab environment but for sensors. Since sensors have become quite small and cheap in the last 10 to 20 years, so it's quite easy to acquire more data on the specific spots you need the data by just placing more sensors. So a lot of work is done there. But of course, when experiments are successful, you want to build data science products. So we also have data science spread out through the company. At the moment, we employ around 60 people who are either data scientists or data engineer. And this allows us to build data science projects for the longer term. We'll talk a bit more about a certain project later on. But we also want to look beyond ProRail and try to collaborate with rail partners, because we want to build even better data science projects that can help the whole rail sector at once. Because of course you have an interaction between our infrastructure and the trains, for example. So we want to work together with NS and Arriva. For example, they measure stuff on the train which we would like to know. Well, then we build a dashboard using the data from NS, and it makes it really helpful for us to track our assets. And one specific project actually uses image recognition. And Oscar, can you tell a bit more about that?
Of course. It's actually my own project, which I'm working on for about a year now. And like I said, ProRail is an asset manager because we have a lot of assets. And to manage our assets, we have to monitor our assets. And the classic way to monitor assets is just to look at them. So in this image, you can see an inspector looking at the track and telling if it's good or not good. But you could imagine with 7,000 kilometers of track that it's not very efficient if you have to look at by hand and with those inspectors. So, and it's not very safe as well, because there are a lot of trains passing by with more than 100 kilometers an hour. I wouldn't want to be there.
Yeah.
And so every time an inspector is inside the tracks, the trains are not driving over there. So this causes a lot of downtime to send inspectors to the working field. That's why at ProRail we come up with an idea. It's called the video schouwtrein, or video inspection train in English. And it's actually quite a simple train, like you see over here, with 10 cameras mounted on them. And it films the complete track of Holland. And each half year we get a complete film made by 2 trains of our tracks, so that we can go through these images and find defects in our tracks. And how do those images look like? Well, you can see over here. There are 10 cameras, like I said, and you have just a front view, a back view, an overview, and a more in-depth views. And there's a video inspector is going through all these images just to find defects, which is quite a hard job, quite an intense job, because yeah, if I'm looking at the screen the whole day, I would get crazy. But yeah, it's a good job. And there are only 10 people in Holland that can do that, because you have to know all about all the defects in the tracks as well. So they can't look at all these images. So how does that look like? Is it you have to track with our inspectors, and there you have the video inspectors. They go through these images and find defects, and they will send to the inspectors in the field to the correct places. So it's much more efficient. But like I said, they still can't go through all the images that we supply each half year. And therefore we thought we have to make this system a bit smarter, and we've got to help those guys going through these images. And so we thought, let's build some algorithms to help these guys, so that it can even go faster. And that's what we started about a year ago. And it looks like this. So let's have a walk through our tracks. Here we can see our tracks, and it's actually each half year we get 250 million images they have to go through. And we can do a little walk and just see what we can find. Well, first of all, we have to spot our assets. So for example, over here we can spot our crossing, and we know which location it has and on which time. But the next step is, you don't want to only know where it is, you want to know what state it is. So let's have a walk again. And we find a current supply box actually, and we have the location, and we can see that it's broken. So we have created an algorithm that can detect if it's broken or not. And eventually, you also have the case that if you know it's broken over a certain amount of time, you can monitor the state, and you can even predict what the lifespan of such a thing is. For example, the insulated joint, like you see over here, we can see that the degradation is already 25%, which is quite interesting, because then we can really plan our maintenance, and it's much more efficient. But how do we do that, Oscar? Can you explain me a little bit how it does work?
How to do that? Of course. So let's move to the computer vision part. So how do we build these models, and how can you do computer vision in general? So computer vision is actually a really broad term. It's basically any vision-like task that a computer can perform. But there are some categories which are the most popular. We can see 2 of them here. So the first one is classification, which is an easy task. You just have to recognize what kind of class is in the picture. And the example here would be a cat. So a computer can recognize there's a cat in this picture. If you want to go a step further, you would ask the computer to also localize the cat, and that he can do as well, as you can see here. But of course, then we're talking about single object computer vision, so that's maybe a bit too easy and not really helpful. But you can definitely go further. You can go to object detection. There you can find multiple objects from different classes. So you can see you can find 2 cats in this picture, as well as a dog and a duck. And if you want to go even further, you can go to instance segmentation, where the computer also has to find the shape of the actual cat, dog or duck. And actually this last step is used a lot for self-driving cars. You can imagine that they need to look around and see where the people are, where the trees are, where the road is, and know it better than just a bounding box. They need to know the exact shape of what they're seeing. So these are some popular applications within computer vision. But still, how do you manage to do this task, or how does computer manage to do this task? Well, by far the most popular architecture is called convolutional neural networks. And this may sound like a bit like a technical term. So we'll go through the words one by one. Convolutional just means summarizing a whole pattern into one number. Neural means it's based on theoretical models of how our brains function. And a network, well, most of you know networks, of course you know a social network is just a group of connected entities. So this is if you divide them up, but how I would explain what a convolutional neural network is would be by saying it's a great number of simple building blocks with many connections between them, and this together allows complex functionality like recognizing a cat in a picture. So what are these simple building blocks I'm talking about? This is actually the convolutional part of the neural network, and it's focused on pattern recognition. So here you can see a small video of how that works. You have the input, which is your image, your picture. In this case, it's really small. And your filter just scans across the picture. And it tries to find a certain pattern. And each filter can find one pattern. A very simple example would be that a filter can recognize a horizontal line. And because it scans over the picture, it can also localize where the horizontal line is in the picture. So this is a way to find a simple pattern within the picture. But now you want to go from there to recognizing a cat. So how do we do that? Then we put the filter, the simple building block, in a big network. I hope you guys can read what's under here, but at the left we have the input, which is your image. Then you have a feature learning step, and you have a classification step. And the feature learning step is where we have all these filters connected in a big network. And we have many filters connected together, which allows to do more complex things. And how this works is that we have multiple layers of pattern recognition, and therefore you can recognize patterns in combinations of other patterns, which eventually allows to find complex patterns. Well, this is a lot of description for what it does, but if you would take a simple example, in the first layer here, it could recognize horizontal lines and vertical lines. And in the second layer, it could find combinations of horizontal and vertical lines, and for instance, find a square. That would be a really simple example of how this could work. And of course, if you add more filters, you can find more complex patterns. But this is still only pattern recognition. Now it has to know if it's a cat or not. So that's why we need the classification step. You have a final translation of all these patterns into classes, which could be cat, dog, duck, or it could be car, truck, van, or bicycle, like here. But in our case, or actually in your case, in your project, it's quite simple. We just need to find an insulated joint, which we just saw in the small demo. And we just want to know if there's an insulated joint or if it's a normal part of the track. So it's either yes or no. Now, you still have this complex network in between of many simple building blocks, but how do you choose the filters to put into the network? For this, we use machine learning. Because if you would have a human decide on all the filters and try them out all at once or a lot in a row, it would take a lot of time to build even a moderate working network. But a computer can do the same thing but really fast. So that's a really good thing you can use, because we just need to design to the network architecture, which is just the number of filters, the number of layers, and the number of classes at the end. In our case, now only 2. And we have a machine to learn which filters to use within the architecture. And it may sound like the machine needs to be very smart to do this, but actually it starts with really bad filters which give the wrong answers. But by trying a lot of different filters in a short time, which a computer can do quite good, at some point it will find the right filters, and it will go from there to improve even more until it can actually do your task, which you ask him to do, a lot better. For this, it needs to know if we give him a picture of a cat that it is a cat, so we do tell him that. But he just needs to fill in the filters in between when he gets a picture of a cat, the filters in between, and cat at the end. and he puts in the filters we need. Finally, we give him a new image of a cat he hasn't seen before, just to test whether his recognition of a cat is really good or not. So it sounds really smart, but actually it's just repeating steps 1 and 2 until your performance is good enough is just trial and error. And humans design different network architectures, try to have the machine learn the filters, and when it works well, it works well. So it's actually not that smart of a process. But it works well, and that's the most important part. So if we go back to Oscar's project, here we have 2 examples of pictures taken off the rail. And on the bottom you have a normal rail track, and the top is insulated joint, right?
Yep.
And now we want to make it a bit easier for the network, so we crop the image so it can only focus on the important parts of the image. And then we can see what the network does with these pictures. So we want him to recognize the insulated joint in this case. So if we have the input of an insulated joint picture, we can see that in the first layer of the network we have some highlights of the picture, and maybe it's not that interesting yet, but you can see that at some point it highlights the insulated joint. In the second layer you can see more output filters giving a highlight of the insulated joint, and even in the final third layer we can see that many of the outputs from the filters give a highlight of the insulated joint. Well, this is what you want, because after this 3-layer pattern check, the insulated joint is quite confidently detected by the model. And of course this only works well if the output for a different input without an insulated joint is different. So let's have a look at that. Well, here you can see that the highlights are quite different for all the filters in the 3-layer pattern checks. So the model can be quite confident in this case that there's not an insulated joint detected. Well, finally let's have a look at how good this model performs. We have a set of about 1,000 pictures, and you can see on the left the truth. So we have, for example, 1,000 pictures where there was no insulated joint, and we see the prediction as well. And for those 1,000, the prediction was also no, so it was correct. And in the bottom right, we see that the prediction for 40 pictures where we do have an insulated joint, that the model also predicts correct. But we still have this 10 pictures where it gets it wrong. It thinks there is an insulated joint, the prediction is yes, but in truth there is no insulated joint. So what happens there? Well, of course Oscar went to find out what the model sees. Well, we see here that a simple leaf on the track can already confuse him. So the evil leaf in this case is in our way to perform at 100%. But still this is quite a good performing model, and we can improve from here, of course.
Thanks for your explanation, Oscar. And now it's time for you to experience these models as well and go to the hands-on. And we're gonna get to the hands-on with your own camera. So why do we want to do that? Very simple actually. Data science is improving very fast, and it's quite an open and fun world, and everybody's really helpful for each other, and it makes it a world which is very accessible even for those people who are not that experienced with coding or Python or any languages for that as well.
Yeah, that's true.
And the other step is that good applications are very easy to build, because when I started with working in this field, I thought building an app is very hard, but it's actually very easy, and all the guidelines are online and it's very easy to do. And finally, image recognition is really fun and super cool, so that's why we're going to build an image recognition model through your own camera. And well, let's give a short demo of what we're going to build, and then we're going to build it yourself.
Sounds good.
So it's demo time?
It's demo time.
Well, okay guys, let's show you the application. First I have to open my Anaconda prompt, because I run my Python files via Anaconda prompt. And I'll activate our environment with the right packages. Activate workshop. So I have the right environment. I will go to the right folder, CD OneDrive, CD repos. And now I can run the file with Python, custom vision.py, but we're in English today, so I'll do the English one. And I'll start the application. Hopefully it runs. Yeah, there it is. And right now the computer sees me, the webcam sees me, and it's projected in the image, like you can see. And I'm currently classified as Anders, or different, and I know I'm quite a bit different, but it's mainly because we created a class that says these objects I can detect, I can make something of it, and we call it Anders. But we can try another object. Oscar, do you maybe have a pen with you?
Oh yeah, I have a pen right here.
Well, what a coincidence. Thanks.
No problem.
And let's try the pen. So I put the pen in front of the webcam, and immediately you can see it detects the pen, and quite accurately as well. It's quite sure that it's a pen. So that's really good. And currently the application only knows one class, but the next step is to find out what happens in the application and what the code is, and then later on we're gonna see if we can add a class. So Oscar, can you tell us a bit more about the application?
All right, well, thanks Oscar for the demo of the application. We'll just quickly go through the application architecture. We want, of course, to explain what's happening in the background when we're performing the demo. It's actually really simple. We have your local laptop, so that's where the Python code is running. And the other component is the image recognition model API. And this is actually called Custom Vision, and it's a Microsoft Cloud tool, which we use for the demo. And what's happening is that your laptop is gathering the images from your video, and image by image it will send it to the API, where we of course trained the model to recognize the pen. And from the API it returns just a prediction of what class the API thinks it is. And then on the local laptop we get the image, we plot the prediction into the image itself, and then we show it to ourselves on the screen. So it goes through this loop, of course, because we have a video, so you have image after image, but that's why it's sometimes a bit slow as well. It has to send it and get back the prediction, so it can show what the model thinks is there. But now you can of course see for yourself how that works. We're going to dive into the code a bit. Not everyone knows Python, so we won't go into too much detail. And then we go to the fun part where you run the code on your own machine and you can test the model yourself. So let's have a look. All right, let's have a look at the code. There are actually some basic steps we're going through, and you can recognize them by the dotted lines. So there are only a few big steps, and if you have experience with Python, you can go through the details, but for anyone who doesn't have experience, you can follow hopefully what's going on through the larger steps. And at the beginning we have the preparation step, which you already did, of course, so it's the packages you need to install. Then we go, when we run the app, through the setup, and we run it just once, so it's all the things we need to do before the app can start, which is making connection with the API, and setting up the camera as well here. And when we have that set up, we can go to the app where we run this loop continuously. And this loop is quite big, but we'll go through it, of course. And we'll go through it over and over again until we ask it to stop. And what it does in the loop, it captures a frame from the camera, and it actually saves it as a PNG file. And then you have the image recognition step, which is code-wise really simple. As you can see, we just open the image file, we call it test data, and then we give the test data to a classify image function, and what we get back are some results. So everything is going on in the background. You don't have to do any more than this to get your results. And actually the largest part of the code is just returning the video image and also plotting in the image the results, like you have seen just before in the demo. So we don't need to go through this. It's just some code to make the square box and to make the text on the top of it. So now we have the image, we have the prediction, and we have put them together. And now we just want to show the video output. So we use this function im_show. It will show the video output. And of course, if we don't do anything, it will go to the next image, ask for prediction, update the video, and show the new video. It will only stop if we ask it to stop, and we use the escape key for that. That's what we programmed here. And then it breaks out of the loop and goes to the final step, which is destroy all windows. So you make sure the app is cleanly broken down. And that's basically what happens. So if you have any Python experience, you can go through the details, but for now, this should be enough. And of course, now it's time for you to run the app yourself. I think everyone has their own way to run Python files, so I don't think there will be any problems with that. But of course, you can look at the way Oscar just did it in his demo, where he used anaconda prompt, which is a popular way to run your code and install packages. So good luck with that. If you have any trouble, of course, you can ask us in the chat for help, and we'll make sure we can get you to run the app on your own laptop, because that's of course one of the most fun parts of the whole masterclass. So have fun, everyone.
thanks Oscar for that great explanation of the code and of the application. But now we have to create a model as well. And well, I'm going to talk to you a little bit about the model. And there are actually quite some problems in this case, because normally for an image recognition case, you have to have about 1,000 images per class to get a good model. That's about the FISP rule. I'm not sure if FISP rule is this the right word, but and in this case we only have a limited number of images because you send us about 40 or 50 images of your hands. So that's a problem, and prefabricated models that we use are actually very good in generic jobs, like recognizing cars or faces. But in this case, for our specific goal, it's a bit harder. Well, actually, hands, it's still a bit easy, but in the demo we're going to show it with the rubber ducks, and it's quite harder actually. So there's a solution to these problems, and that's called transfer learning. And transfer learning actually recycles the feature learning from a different model. So here we have the model, the image that Oscar already explained about, and we actually have the same architecture as before, and which predicts car, truck, van, or bicycle. But now the input is different because our input is rubber ducks. And we want to use this model from the car, truck, van, and bicycle. So we use that feature learning. So the features that the first model has learned, like horizontal lines, vertical lines, we're going to reuse from a different model and actually just remove the classification part from the car, the truck, and the bicycle, and replace it with our case. So pen, wristwatch, or yeah, in this case, rubber duck. And in that way we can use already learned patterns to relearn a different case, and it's actually quite good. And a lot of big companies make these models. For example, Microsoft has some solution, or if you're online, sometimes you have to say that you're not a robot and you have to click some images, and then actually you're training those models. And we can reuse those models for our rubber duck case. And that's what we're going to do today. So we already saw how the application works, but it only works with a pen right now. And we're going to add a new class. We want to add these rubber ducks to our class so that the application can recognize the rubber ducks. And to do that, first we have to upload some photos, add the class to the model, retrain the model, publish it, and then put it in our application so that we can use it. And it's actually quite a simple step, which I'm going to show you right now. So let's go to the live demo again. Well, okay, so let's have a look at custom vision, and we're going to create an extra class. Oh. Oké, even opnieuw. Well, let's look at the custom vision, and let's see how we can build a model and create an extra class. And we're going to do it for the rubber duck. So I will open an internet browser and go to our webpage, customvision.ai. Actually have to sign in still. Sign in. Well, it's a semi-live demo, and it's not always working perfectly, of course. Hopefully I will still remember my password. And there we go. And I can see our project for today, custom vision test. And oké, nou opnieuw dan. Nou ben ik wel ook ingelogd, dat is ook chill.
Ja, dat is geen goede.
Oh, ik ben ook mee aan het kijken nog.
Nice. De homepage die gewoon open. Nou ja.
Zo. Well, okay, guys, let's try to add a class to our already working model. And we're going to use custom vision like we said. So I will open my internet browser with customvision.ai. And here's our project, custom vision test, that we already used for the previous application. And I open the project and we can see that on the left are all our classes. So actually we added already some other classes like watch or pen, wallet and keys. And we, like we said, we already had a class for different. And if we open that class, we can see all kinds of different photos of random things like myself or a cup or the other Oscar. And in that way, in that manner, we have all types of images of our classes that we train upon. And on the top, you can see that we have the training image, we can see performance of our model, and we can actually retrain our model. But for now, we want to add an extra class. So we press add images. And it opens correctly to our rubber duck folder. And we have a lot of images of rubber ducks. Well, actually only 21, but it's sufficient for this model. And it's the same amount of hand images that you send us. So let's open it. And we can add a class to it. So let's let's type rubber duck. I think that's the correct name. And let's upload these files. Might take a moment, but actually we're doing these steps live with the same steps live with the images of your hand. So we're actually adding those images to this project and adding a class we will call left hand. And well, it's a live demo. And not everything works correctly, so I'll try it again. Not sure why it didn't work. Upload the files. And hopefully, like I said, semi-live demo, and it's not always working perfectly, but hopefully it works right now. There you go. The 20 images were uploaded successfully, and now we can see them in our project if we select the rubber duck class. And now we can retrain our model so that the current model learns to recognize all those images and can see that those are rubber ducks. So let's train, and this time we'll do a quick training because the advanced training costs money and we don't want to do it, and it's quite a bit faster. So let's train. And right now, the computer is going through these images and looping through these images, finding those patterns and the correct filters to predict if it is a rubber duck or not, and also the other classes. But luckily, this might take a while, but luckily we already trained a model. So let's try iteration 2. And that's an already trained model. And we can see it has the bot eend, same thing as rubber duck. We give this course also in Dutch sometimes. So we have a trained model on those classes, and we already published it, and it's over here. And here we can see all the metadata from this model. We use this published name, multi-class 1, and we're going to update our application with this model. So we'll reopen the model of the code for the application. And you see here the published name. So I'll replace it with multi-class 1, and I will save it by pressing Ctrl S. And actually, if I rerun the model right now, rerun the application, so I'll run the application and hopefully we can see my head again, and I'm still quite a bit different. But now we can have a look if we have some different classes, and hopefully Oscar has some objects for us to detect. Do you have maybe some keys with you?
Oh yes, I have a pair here.
Great, thanks. So I'll put the keys in front of the webcam, maybe my head a bit to the side, and you can see, it really detects the keys very well. And we only had about 5 images, which is very cool to see. And so it's really easy to learn something, but this time it was about the rubber ducks. So you might wonder why the rubber ducks were on the table, but yeah, so it's for this solution. So, oh, something went wrong. Let's have a see if I can restart it. Yeah. And let's test the rubber duck. Ah, there you have it. It's a butt end. And we can test another one, and hopefully it works as well. Oh, still different, but butt end. So the model is really good, and we only used 20 images to learn this model what a butt end was, a rubber duck. So that's really cool to see how easy it is to create a good model. And I think we added some different classes as well. So maybe, Oscar, do you maybe have a wallet with you or a watch?
Oh yeah, I have a wallet right here.
And a watch as well. So let's see if it if it recognizes the wallet. Ah, very good.
Portemonnee.
And the watch. It's a bit more difficult. So maybe if I go to the side and yeah, there it is. Because it's easier with a white background, so there's less noise. So now it's time for you to try it yourself, maybe?
Yeah, you can try now with the new hands class, see if it works.
Yeah, so we're gonna try. We're gonna try it ourselves. So we updated the model for you with all the images of the hands, and we're really eager to see if the model works or not. And hopefully you can send some images of some print screens of the model of the application and see what you can detect, and if it does work for with the hand images, and if it can recognize your hand, and hopefully it does. So let's try and start the application for yourself and you can send in the chat some print screens. Good luck, guys. So now we've updated the model, and actually in the backend we updated the model with your images of the hands, and we updated the class. So let's see for yourself if the model actually works and if the application actually works. So you can try the application on your own laptop just by renaming the published name to the name we put in the chat, and then run the application again. And we're really eager to find out what kind of things you see. So maybe you can post some images in the chat of what you see, and if the model does work or doesn't work, if it just only says that everybody is Anders.
It would be really cool, yeah. We're also curious to know. Yeah.
But we think it's gonna work, but maybe it doesn't.
Yeah.
You know, it's semi-live, so hopefully it works. Good luck, and let us know. thank you guys for all those really cool response in the chat. I think the model works. Well, actually, I don't know because it isn't live. But
It probably works.
It probably works, right?
Yeah.
Let's say it
confident,
works.
we're
Yeah.
confident.
And the images you said were actually look really cool. And we really had fun to create this masterclass for you and to do it.
You have a good idea of now how computer vision works.
Yeah.
And you might try to work with it yourself or try to build an app like this because you can see how easy it is without knowing exactly how to build a model yourself. So
And if you have any questions or you want to go get into data science yourself, just send us an email and we're really happy to help.
definitely, yeah.
Because it's such a cool role and we love our jobs, I think. So
Yeah, definitely. And have fun, of course, with Hackatrain. Good luck with the
good luck
competition.
for the next days, I think.
Yeah, 2 days. And good luck, everyone.
Bye.
See you next time.
Thank you so much, Oscars. I'm very happy that you were able to do this from home. Now, up next, we have 2 more workshops for you. Yes, in about half an hour, they're going to start kicking off. Links will be in Slack. One is going to be from Shell. They're going to be teaching you all about design thinking. And the other workshop is going to be from IBM, and it's going to be all about going from mock-up and going beyond a mock-up really and going to a prototype in a very short amount of time. So there'll be lots of great tips there, lots of great things to help you get productive. So we'll see you in about 30 minutes. Looking forward to seeing which one you choose. Bye-bye.